Since we are given this question, if z1, z2, z3 are complex numbers such that modulus of z1 equal to modulus of z2 equal to modulus of z3, which in turn is equal to modulus of z1 plus z2 plus z3 equals to 1, we expected to find the value of modulus of 1 over z1 plus 1 over z2 plus 1 over z3. The most important observation you have to see here is this statement or this relationship that they have given, which is modulus of z1 is equal to 1, modulus of z2 is equal to 1, modulus of z3 is equal to 1, and modulus of z1 plus z2 plus z3 is equal to 1. So we would be using all these three relationships to show that, or to find the value of modulus, in other words, modulus of 1 over z1 plus 1 over z2 plus 1 over z3. So we would do that now. So I would start off by using this relationship. So we are given that modulus of z1 is equal to 1, and this would mean if I were to square both sides, I can rewrite this as modulus of z1 squared is equal to 1. Okay, now we know that modulus of z, its square, if I were to take its square, then that is going to be rewritten as z multiplied with z bar. Okay, so this is true. We know this. Okay, if you want, I can show it. I can show the truth of this fact now. So if I were to take z to be as, a positive ib, then z bar is going to be a negative ib. Now, if I were to take the modulus of z, which is going to be root of a squared positive b squared, and if I were to square this, modulus of z, if I were to square this, it's going to be root of a squared plus b squared, and that has to be raised to the power 2, which is going to be a squared plus b squared. So this is what we get. Now, on the other end, if you were to consider z times z bar, z is a positive ib and z bar is a negative ib. If you were to take their product, this is going to be a squared negative I squared times b squared, which is a squared. I squared is negative 1, and that multiplied with the negative sign would give me positive, which is equal to positive b squared. Now what is this? This is exactly the same as modulus of z squared. So this shows modulus of z raised to the power 2 is equal to z times z bar. Okay, so that is just to show you that this property is true. Okay, now because of this property, I can rewrite this as z1 times z1 bar is equal to 1. From here, I can rewrite z1 to be as 1 over z1 bar. Okay, so I can do that. Now, you should know that we were given that, also given that modulus of z2 is equal to 1 and modulus of z3 is equal to 1. So this shows I can simultaneously write z2 to be as 1 divided by 1 divided by z2 bar, and for z3 I can write it as 1 divided by z3 bar. So I can simultaneously rewrite all of these things. Now you have to know that we were not given as z1, z2, z3. We were asked to find, since we are asked to find the value of 1 over z1 plus 1 over z2 plus 1 over z3. Okay, now z1 is 1 over z1 bar. Okay, but if we were to take the reciprocal of this, then we would end up with, I can state here, therefore 1 over z1 is going to be equal to z1 bar. Okay, now how do I get that? I'm going to show that to you here. Now z1 is equal to 1 over z1 bar. Okay, you agree with that? So if I were to consider 1 over z1, now 1 over z1 was going to be 1 divided by, in place of z1, I'm going to substitute 1 over z1 bar. So if I were to flip this, 1 over z1 bar would be moved to the numerator. It's going to become z1 bar. Okay, so that is the property that I would be using here. So that is going to be equal to, this is going to be z1 bar positive z2 bar positive z3 bar. Okay, this is what is it. Now you have to know these are all sum of the conjugates. Now by property, z1 conjugate added with z2 conjugate, and that can be in fact rewritten as z1 plus z2 the whole conjugate. Okay, that means the modulus of the sum of the conjugate is equal to modulus of the conjugate's sum. Okay, so because of this property, I can rewrite this as modulus of z1 plus z2 plus z3 and take the entire modulus. I can do that. Now since I have the modulus sign here, you have to know that modulus of z is same as the modulus of its conjugate. Okay, it's not going to make any sense. So why I'm going to show you here. Now let me take z to be as a positive ib. Then z bar is equal to a negative ib. Okay, now if I were to take the modulus of z, this is going to be root of a squared positive b squared, and I take the modulus of z bar, this is also going to be root of a squared positive b squared. Okay, because the signs doesn't matter for us. Okay, because we are squaring. Now because of this fact, I can rewrite this entire thing to be as modulus of z1 plus z2 plus z3. But we are given, we know that, what do we know from the question? We know that modulus of z1 plus modulus of z1 plus z2 plus z3, this is given to be equal to 1. Okay, so this implies this is equal to 1. So this in turn means modulus of 1 over z1 plus 1 over z2 plus 1 over z3 is equal to 1, and that is the final answer to the question.